Here we go. Yes, obviously I'm Paul Matthews. Thank you very much for coming along. Big thank you to Hello Self for having us, and Mike in particular, who somehow managed to get this stand-up desk after I was being a big old prima donna, saying I couldn't type down there. So, first thing I want to say is that I'm a career changer. So I'm still quite new to Scala, quite new to functional programming, and I started learning Scala when I joined ClearScore just over a year ago now. So today's kind of a beginner-focused talk using algebraic data types to model music. So I'm working in financial technology at ClearScore, and I'm here today modeling music instead of financial products. Why am I doing this? I'm going to tell you, but not before I outline what we're going to talk about today. So first up, this is the question that I want to answer. Can we model music in Scala? And on the way to answering this, I'm first going to go over the use of algebraic data types to model and describe music. Then I'm going to go over some ways to improve the resultant sort of API and domain-specific language to make it easier to write and arrange some songs. And then finally, we're going to write a song on the fly and we're going to have a listen to it. Now, I have not been doing Scala long enough to be doing live demos, so that is the fun part. It could be a disaster, and you should laugh. All right, so why I'm modeling music here today. So firstly, this strange accent that I have with the mono vowel, this is a Kiwi accent, all right, because I grew up in New Zealand. And before becoming a Scala developer, my first career was in the music business. I wrote songs and I played in bands, played in signed bands. There's a big difference between a signed and an unsigned band. I worked in recording studios as an audio engineer. And I'm still a huge fan of saying it out loud, but factually, in New Zealand, I am classified as a rock star. It's hard to say. And other Kiwis, they get quite upset when they hear me say it, because it goes against the whole humble culture there. And I do get it, because there are a number of things you're not meant to call yourself. But this is a data-driven assessment, all right? So up here on the slide is some data. Had a bunch of number ones, had some platinum albums, spanning a few decades, even though I'm not that old. I've been signed to all 4 of the major record labels at one time or another. So I'm not going to fight the data, and I don't think you should either. But I'm going to share with you some of the sorts of highlights of that period. So this is the first thing that could not work. All right, here we go. So I'm gently fading the music out to show you this photo. Now when we were touring with Slash in Australia, high point in my career to be honest, because he was one of my heroes when I was growing up. So now my music career it spans some very big changes in the music business. I did evolve too up to a point, but as a predominantly rock artist and audio engineer, I just wasn't going to make the jump to influencer on TikTok, and so I had to have this hard look at where my career would go next. Now so this hard look, it prompted me to pivot and actually leave the music industry. And I enrolled in a computer science degree at the University of Hertfordshire. Well, there we go. And again. Oh, and again. Told you it's a prima donna. All right. So I graduated at the end of 2020, and in July of last year, back-end developer opportunity at ClearScore came up. And so I Googled Scala for the first time, and then I applied for that job. Now, because I was a Scala newbie, they sent me straight into Scala beginners training, which they had running, and it's being led by a gentleman of the name Noel Welsh. And so I started working through one of Noel's books called Essential Scala. And there's an exercise in that book on using algebraic data types to model music. So if you're quite new to Scala, I encourage you to give that exercise a go. And so you can imagine that for me that exercise sat very well. And it enabled me to make a big song and dance about something that I could actually already do. So this project today is actually just the continuation of that exercise. And once I had this data description for music, it was obvious to me that I should try and use it to make some musical noises come out of my computer. So this is what I did, very, very crudely using 4 voice samples that I recorded through my MacBook mic with QuickTime. So, you kind of saw me playing it before, but I'm going to dive right in and do a bit of a sound check on my virtual instrument, Scala Redwood Grain. So here are these voice samples I was telling you about. I tried to warn you they're a bit rough. But yeah, I've also got these drum samples up here. Here's a kick drum, it's a snare drum. I'll tell you what. So initially I was like, hey, let's do something really cool and compose a song using only my voice. But that did not age well. Probably about 17 minutes before I found that noise in particular hard to listen to. So fortunately I've got some nice sounds. My friend Harvey here, he recorded some guitar for me. I don't know why. But yeah, so the coolest thing though about these ADTs was the ability to sequence a tune or a melody, which I did, once I can find the mouse again, over here. So of course, being a bass player, the first thing that I'm going to try and sequence up is a bass line. I'm going to play this bass line. Are you sure it's funny? Yeah. Well, anyway, can anybody actually tell me what bass line that is? Anyone who doesn't know? Can anybody recognize it? No.
Is it the Blue Double song?
Not quite. It might be the same chords, but no, this is actually the bass line for With or Without You by U2. And so yeah, my mates at work are a bit like, you sure you want to publicly discuss U2? Well, I do have to, because in terms of bass lines, they're a rudimentary starting point for me in using ADTs to create a sequence, because the bass line consists of 4 notes and then like a large amount of repeating those 4 notes. Not a great deal of imagination, but so in the set of all the bass lines I know, 30 years worth of bass lines, With or Without You is of course the closest thing I've got to an identity element. There you go. Alright, so I'm going to rock on back to, there we go, got that out of the way. Yeah, sounds of structure, so you've heard some sounds now. We're going to get onto the structure thing, but first I'm going to fill you in on the UI, how I'm generating those sounds. These are the tools that I used to build it. So I imagined you noticed that I was like running it in a browser. So it is actually like a Scala.js app. It's wrapping a JavaScript library called Tone.js. It's a very excellent library. It sits on top of the lower level web audio API. And then I've used Laminar for building out the UI more. Cool, so on to the structure part. What is an algebraic data type? Who here already knows what an algebraic data type is? Come on, really. I know more people know it. Okay, cool, not too many people. Well, up until last September, I'd never heard of them. But here is an ADT. And this is my first sketch of this book exercise on modeling music, which I did by describing 4 different music events. So on this first line, we introduced like an overarching music event type, or a sum type. And the possible variations of a music event in note, rest, melody, and harmony. And these are all product types that we're implementing with case classes. Now I do just have to clarify what each of these music events represents, because I can't take it for granted that everybody knows what a harmony is, for example. So first up, the basic single fundamental sound unit, a note. Cool? So next we have like a melody, right, which is a sequence of notes joined together and played over time. So, alright, that's a melody, for those who didn't know. Next up we've got a harmony. This is like 2 or more notes played simultaneously, like that. Here's a 3-part harmony. Alright, so that's a harmony, okay? If you play it on the same instrument, you normally call it a chord. And then finally we've got the rest. So in a melody we have a pause. This is what a rest is. It determines how long we're going to pause for. So when I first heard the term algebraic data types, I thought they were going to be more complicated than they turned out to be. So ADTs, they're simply a way to describe our data in an expressive and type-safe manner. And so we use the Scala type system to define our data structures in a way that makes it impossible to create invalid states. We can then pass these descriptive and expressive values around our code, and we can use algebraic operations to combine values and create new values. So we just saw that when we just heard that, when I combined one note with another note and made a melody, which is an algebraic operation. So hopefully this here gives you an overview of what an ADT is if you haven't met one before. And so here's my final description of a music event. And you can see it's like evolved somewhat from my first attempt. So firstly, I've added this drum product type, just so we can program drums and arrange drums and songs. Now, I played you those drums very briefly before. And secondly, note here, it has a few additional fields. And so this evolution shows that it's taken me like a few attempts to get something that's going to fit my aspirations. And modeling data this way, I think it's something that we improve it the more that we do it, and the more that we learn about the domain that we're modeling. So what I'm going to do is I'm just going to go through all these fields that define a note. So music is constantly evolving. Obviously, it evolved faster than I did. So one of the things that hasn't changed much at all, though, is that we're still using the same set of Western music theories, namings, timings, pitches that we've been using for hundreds of years now. So apparently these basic diatonic notes, these are the ones that go from A to G. Apparently they've been around since the late Middle Ages. So if you weren't too busy trying to avoid the bubonic plague or draft dodging holy wars, you may have been found sitting around playing these very notes on your lute or your harp. This is how you play a harp. Have we got any harpists in the house? Nah, well that's how you play it. No. So these are the properties that we need to model with the note product type. So here we go. The first up is pitch, which is like the actual term for the note's name, which, as I mentioned before, ranges from it's the letters from A to G. Now I've used like another ADT here, note name, for modeling these. And here's a quick look at that. And you can see that using this note name type, only these 7 note names are possible. And it places a constraint on the values we can use, and it guarantees type safety for a note's pitch value. Because if, say, I use a character or a string instead, which would be the obvious and traditional route, then we would be able to do things like this. So for the actually, I know this gentleman at the back here, he's a musician. What does that note sound like to you? That's right, because it's not a note. So, and if he can't play that note, you can imagine what ToneJS API is going to try and do when I offload that note to ToneJS. And don't forget, it's a JavaScript library. Every bit as salty as you'd expect. Runtime error. So using this note name ADT is going to prevent this particular runtime error from happening, which is cool. All right, cool. So on to the next of these properties. And we've got this accidental here. This just determines whether a note's going to be sharp, flat, natural. And then next up is duration, how long we play a note for. And next we have velocity, and this is a controversial integer. We're going to find out why. I'm going to talk about velocity more very shortly. And then finally we've got octave, right? So this is like higher and lower versions of the same musical note. I'm just going to show you on an instrument, because last time I did this I sang it. Then I watched the recording back and I was a bit flat on the octave, so I got upset about that. So here's an A, and here's an A, A. Right, so that's an octave, right? It's the same note. Cool, so these are all the properties that I've decided at this point I need to model a note. There's probably a few more, but this will do for now. Cool, so what I'm going to do now is I'm going to show you an example of using an ADT to model the velocity value in our note model. So at the moment, our velocity is actually dangerous. Now velocity is the value that determines how hard or soft a note's played on a digital instrument. In this project, it provided the ideal opportunity to learn about and demonstrate type safety, because after all, we're wrapping this JavaScript library, and we've all long suspected that JavaScript is the indigenous homeland of the runtime era. And of course, working out how to wrap this library and make some sounds, I had runtime errors coming out of my ears, so I've been there. And with my background in audio engineering, my default understanding of velocity is MIDI velocity. Does everybody know what MIDI velocity is? No one knows what MIDI velocity is. Yeah. So I'll explain it. So MIDI is an acronym for Musical Instrument Digital Interface. Dates back to the early 80s when we still had loads of good acronyms left. It's a standard protocol for sending digital music data between digital synthesizers, keyboards, computers. 7-bit value, 0 is silent, 127 is the loudest. So modeling velocity with an integer is not great, because we can obviously easily exceed 127 and have negative values, which won't work for MIDI. However, there is an even more sinister issue in that ToneJS has a different implementation of velocity, and instead it takes velocity values ranging from 0 to 1. So you can see where this is going, right? And you can see on the slide here, I'm instantiating this note, I'm passing in a pretty modest 105 for velocity. Sadly, however, it's 105 times too much for poor old Tone.js, so we should definitely have a listen to this. Cool, so over here, this button's going to play a vocal sample, a really nice vocal sample, over in Tone.js.
Here we are, born to be kings.
Nice. This one, however, is going to send it off there. Instead, the first one was at the max velocity of 1. This is going to go over at 105. I want to turn it down a little bit because last time people got upset.
Turn it down.
Yay. I'm interested. I want to know. Did anyone here actually like the second version better?
Yay, distortion.
Yeah. That's the thing with the arts. You can always find someone. Yeah. So, however, doesn't matter whether you liked it or not. That sound of like flame grilled JavaScript. It's not what we want. Not the desired behavior. And ultimately, this note's velocity value has an invalid state. So the solution, you guessed it, we're going to write an ADT. I'm going to propose an ADT. And this is what I propose. And this one looks a little bit different to the other ADTs you've seen, because this is a Scala 3 style ADT, using the enum construct, because we're all going to Scala 3 now. And you can see here that I've discretized 128 MIDI values into 8 buckets. And that get normalized velocity method at the top there, it just takes care of the conversion to the Tone.js format, just so we can have both formats, and then I can carry on using the same MIDI values, which I've been using since like 1997, and I like. Cool, so here we have this type-safe set of velocity values, and we have to make a distinct and intentional effort if we want to blow up synths and samplers, which of course we've done here at the bottom with Napalm, which I included, solely so I could show you that, devastated napalmed vocal sample. So I can take it out now. And I just want to make a quick case as well for like readability and expressiveness. So here's an instantiation of this original note case class. And we can read most of it, but for a first-time reader, there's no way of knowing what 2 or 105 is for. Of course, we have name parameters, which are great. Or we can just explain it with the argument name, as we've done here by passing in a value called loud. So we're creating a musical DSL. And as a musician, the term loud for me is definitely more expressive than 105. So if you say to me, hey mate, can you play me a C105? You're going to get a human runtime error, because I'm going to be confused. I might even be offended that you're trying to trick me. If you ask me for a loud C, however, better or worse, probably my default setting. So without hesitation, you will probably get that. You will get it. So looking at this now, this is actually like a specific note. It's got all the instructions there. Cool. So now we've got a way that we can describe music, the algebraic data types. So now we need to get to work. We need to use all this to write some music. The thing is, at the moment, it's not actually that easy to use it. So here's an example of our note implementation instantiated. 4 very simple 4-note melody, 4 of the same notes even. It doesn't even fit on an industry standard PowerPoint slide. And you can imagine what this whole 4-minute song is going to look like if you try to do it in this manner. Not very manageable. So the solution to this is to use builder methods or smart constructors to define a nicer looking, more usable, more concise API. Now before I go over the builder methods I used in more detail, I'm quickly going to show you what this last 4-note song looks like in the API that I'm proposing. There you go. So I'm going to wait for you to finish clapping. Because we have a one-liner, and of course we're all crazy about one-liners, right? Same 4-note melody, using builder methods, a lot more concise, and I'm going to say it's expressive. And this is what we want to use the builder methods to achieve. And you can see that we're starting each note with like a note name definition and passing the octave in. Then we're calling the sharp method to sharpen it, followed by an 8th method to set the length. And each time it actually returns like a new note instance with the new value. And so here we're using like immutable data structures. My like indoctrination in functional programming over the last year, it's all about immutable data structures, right? So, and you can see I'm using this asterisk at the end there to repeat it, and then 4 times. But like more to the point, we can actually just read what it says. It says C#8 4 times. So not only does the syntax like really speed up the process of writing out some tunes, but we can create like readable notes and melody sequences that musicians can read. Cool. So here's a quick look at the, I've got to hurry up because I do want to do a demo and sort of running out of time, but so just going to quickly go through these methods. And first up, these are the note methods for all the fundamental note names, purely so we can start the note definition with the name of the note rather than having the word note written in the definition. Then the same thing here with the drums, just making a more concise way of finding a drum. Next I've got these sharp and flat methods, so I can set like the accidental of a note. And these are calling like other sharpen and flat methods that I've got in a utility object. So I'll show you those. Here's the sharpen method. It's a small section of the sharpen method anyway for the A note case. And basically I'm pattern matching on the note and then returning a copy of that note half a step higher than it currently is. So if you have an A flat, it becomes an A natural becomes A sharp. Next up, duration methods. You can see there's nothing too complicated here. Again, they're simply just returning copies of an existing note with the new length that we want. And one of the best things about these builder methods is that there's no sort of great learning uptake. They're very simple, but they do wonderful things for your API. Same for velocity, just like duration, new note, copy of the previous one, but with the new velocity value. And here's our repeat method. I'm just going to rock on because it does what it says. And then I've got this little, I use the asterisk to define that, purely for aesthetics, right? So I don't have to write repeat. Yeah, and then finally I got this pipe symbol. I haven't seen it till now, but it basically serves as an algebraic operation for joining notes together. I used it because it resembles a musical bar line. It was like the most musical symbol I could find. But it actually only correctly serves as a bar line when it's joining notes between the bars, yeah? But so this DSL, it certainly isn't like lexically perfect in terms of Western music theory, but it is close enough for me and it's very usable. And hopefully you agree with me that this is better than this. So, awesome. So those are the methods that we need to make like a description look as natural as possible for describing a single melody or a tune. But what if we want to write a whole song? So for this I have this song type here, and in this voices field at the bottom there, that's going to take multiple music events and play them simultaneously. It does that with a non-empty list of channel voices, which defines the instruments in the song and the music events that they each play. So here's an example of a channel voice. Once again, bass comes first, and this is the bass channel. And you see it takes a music event, and it'll then play these melodies and notes with this instrument and voice. So this song type also enables the description of a complete multi-voice song in the vein of a musical score. And so here's an example of that. And this is the DSL in action. It's an instantiation of the song object. It describes a complete song with drums, bass, guitar, piano. It's not a long song, but it is a song. And I feel that now we've got something that is expressive, it's readable, and it more closely resembles, maybe not so much a score format, but like a chord chart. I've got like different spacing between the notes and that to define how long they're played. So this is what the song looks like. Let's have a listen to what it sounds like. Turn up a bit. And there's it. Yep. You gonna quit? All right. Thank you.
I was
All
not
right.
desperate, Paul. That was just.
Let's have a do it, mate. All right. Okay, now I've got to hook to my IntelliJ. Let's get this sorted out. There we go. All right, cool. Everyone can see that, right? That's big enough? Oh, come on. I'm at risk of messing it up if I make it any bigger. I'm at high risk anyway. All right, so this is what I've actually got here. This is a song. I've got this hi-hat already defined. Does everyone know what hi-hats are? Yeah, great. Then it's all right, cool. Let's have a little listen to the tune here. This is what we've got at the moment. Alright, so we've got a starting point, okay? So we need to finish these drums off. I'm going to get you guys to decide between a dance song and a rock song. Do you want a rock song or a dance song? See? I knew you guys were rockers. I was hoping so. I mean, the dance song would have been finished in 10 seconds, but... So, first thing we need is a channel. Kick channel. So I've already gone and done something. Okay. Right. Kick. Okay, so we want to have the kick on the 1 and the 3, right? So I'm going to put a kick here. Actually, I've got a better kick than that. That one's the mouth noise one. I want to avoid that if I can. So we've got a vinyl kick. We're going to do a rest for a quarter. You know what? I'm just going to loop that. It's going to be fine. So I've got this like little loop method. I'll show you what it does, eh? We'll go here. Now you can see it's not really a loop. It's just a repeat for 48 times, but it's working. All right, let's have a listen to that. There we go. But down the bottom there, you can see it compiling the JavaScript live. Oh yeah. It's slow. Slow. So what we're going to do, we're going to have a snare drum now. The snare drum is the kick. That was the worst sound that came out of my mouth. So I'm going to definitely not use my mouth sound. We're going to rest on the 1. Rest on the 1. We're going to come on the 2. I mean, this beat here, it's not the original, but it's the one that's made like all the money. So it's pretty famous, like ADTs, Eminem, all these guys. I mean, they're quite similar. Right, I say it's too slow. So let's speed the tempo up a bit. 128. Painful compiler JavaScript, alright? Here we go, let's have a listen to that. Alright, cool. Drums, everyone's partying. Alright, next up's going to be the bass. Here we go, let's look at that. Of course, we need the bass channel. Bass channel. So we're going to do some notes now. Pick a note. Someone pick a note. G. Thank you. I was going to say C sharp. I was going to get angry. G. Let's do this. G8. G8. And then we're going to go times 8. And then we're going to go. Cool. I'm actually making it up. Seriously. We're going to go 8 again. We're going to go times 8. Okay. 4. F. That is going to be maybe alright. Of course, we've got to loop it. Oops. Awesome. I'm very excited. Here we go. That's what happens when you play the bass like really high up in the string. So I made a mistake. The mistake was that I did not pass in the octave. So let's get this here. 1. 1. Oh. And 1. Then we're going to be back in business, I think. I feel like we should get on and do the guitar though, because we're running out of time. Let's have a quick listen. Alright. Are you convinced? Alright, cool. Alright, cool. Yep, no worries. And the G has thrown me a tiny bit. This is a major start. It's okay. Guitar channel. I'm going to be quite cheap actually. And I'm going to do this guitar channel. I don't even think it's called guitar channel. Rhythm guitar channel. Let's have a look at that. There we go. Let's use that. For some reason I'm not getting any like code completion. So I'm handling it very well though.
Should use metals.
Let's go.
Get it out of here. This is my trick. I'm just going to grab this whole thing. Actually, I'm just going to do this. And then we're going to We're going to do exactly the same thing on the guitar. Comma's going to be a problem. All right. Awesome. Right, let's go. Oh no, what do I do?
Did you change the octave?
Yeah. Right. Cool. I'm going to do one last little thing. I'm just going to, we're in the key of A minor really. I'm going to just like pedal point motif. I'm going to try and speed this up. I'm going to try and do it very quickly. Moody piano channel. What is that? Oh, moody piano channel, we go. Cool. I'm going to go like A, I'm going to go eighth. We're going to stick that to a ACE. We're going to do like this little pedal point arpeggio on A minor. Eighth. ACE, eighth. G, ACE, G, eighth. Right, here we go. I'm going to go this. I'm going to loop it. I can't make any promises, but it's going to be a song anyway. So here we go. Sure. I'm going to call this one Ode to Anton Sviridov. You put me wrong, mate. But yeah, that's still a song. It still works. You can still call it art. So that's what we're trying for.
I was like a rock song.
What's that?
You asked for a rock song.
That's right. Roman. The best thing about Roman is he just carried my speaker up the stairs. It means it was constructive. All right, anyway, that's all we've got time for. I want to say thanks very much for coming along. Thanks, Roman, for carrying my speaker up the stairs. Thanks to Mike for appeasing my prima donna ways. What we looked at was algebraic data types to describe musical data, musical events, and musical arrangements. We then looked at how we could make the API and DSL more usable and better looking. And then finally we demonstrated that by writing the Ode to Sviridov song there. So, also want to talk about Scala Bridge. If you want to learn about ADTs, because not many of you put your hands up, you can get your phones out now, you can come along and we can teach you how to do it at Scala Bridge. There's Zainab's in the back there, she can talk to you more about that. But yeah, there's the most amazing Scala trainers there, not me, but yeah. I mean, I'll be there, but you're better than me as well. All right, can we make music with Scala? I want to take your views on that. I've got like 1.5 minutes, I'm going to take questions. But other than that, that's all I have, so thank you very much. No questions.
Just expected more from a rock star.
That's all right.
Named rock star as well.
Thank you very much. No questions. Thanks. I'll leave it at that.